Hello, dears. Welcome to the Science for Sleep channel. Tonight, as the noise of the world fades away, we turn our attention to something vast, ancient, and quietly breathtaking. Above us stretches the Milky Way, a river of more than 400 billion stars, drifting through a universe that has been expanding for nearly 14 billion years. In this journey, we will slowly travel through our home galaxy, from its glowing spiral arms to its mysterious core, exploring how it was formed, how it moves, and why it exists at all. There is nothing you need to do. Simply listen and let the galaxy unfold. If we could somehow escape Earth's gravity and rise above the stars, we would see our galaxy, the Milky Way, not as scattered points of light, but as a vast, glowing wheel suspended in the emptiness of space. From the outside, it appears calm and orderly. Yet beneath this quiet surface lies a restless and ongoing turbulence. Within it, stars are constantly being born and quietly fading away. Entire star systems drift and spiral at astonishing speeds. Immense clouds of gas are pulled apart, compressed, ignited, and at the very center of it all rests a monster of truly epic scale. Only recently have we begun to understand what the Milky Way truly looks like. We have traced the shapes of its spiral arms and identified the smaller galaxies that orbit around it. And still, much of it remains unknown. On this journey, we will follow those faint threads and slowly piece together the story of our galactic home, one of the greatest narratives the universe has to offer. If journeys like this, where past and future quietly intertwine beneath the stars, bring a sense of calm to your mind, you may wish to subscribe to the channel and support this episode if you haven't already. Your presence and encouragement help these deep explorations of the universe's quieter corners reach more curious minds. Now, dim the lights, let yourself drift, and settle into the flow. We begin. Long before science gave it a name, and long before humanity understood what stars truly were, there was a pale band of light stretching across the night sky. People all around the world could see it clearly on dark, cloudless nights. It arched overhead like a great celestial road drawn across the heavens. Some believed it was smoke. Others imagined it as a river. Many thought it was a trace left behind by gods or wandering spirits. This was the Milky Way, though no one yet called it that. In those ancient times, people did not think about space the way we do today. They had no instruments to measure distance or light. There was no way for them to know that this faint glow was made up of countless stars. All they possessed were their eyes, their stories, and the open sky above them. Among the first civilizations to give names and meanings to the stars were the ancient Greeks. They saw the Milky Way as something born from myth. One of the most well-known legends tells the story of the goddess Hera and the infant Heracles. According to the tale, Heracles, born to a mortal woman but fathered by Zeus, was placed beside Hera while she slept, so that he could drink her divine milk. When Hera awoke and realized what was happening, she pushed the child away, and her milk spilled across the sky, forming the Milky Way. The Greeks called it Galaxias Kyklos, the Milky Circle. Even the word galaxy we use today traces its roots back to this story of spilled starlight. In ancient China, astronomers carefully recorded the movements of the stars over centuries. They had their own name for the Milky Way, the Silver River. To them, this glowing band was a celestial waterway flowing across the sky. One of the most beloved stories connected to it is the legend of the Weaver Girl and the Cowherd. In this tale, two lovers are separated by the Silver River and are allowed to meet only once a year, when a bridge formed by magpies appears in the heavens. Today, the stars Vega and Altair still represent these lovers, shining on opposite sides of the Milky Way, their positions shifting gently with the seasons. Farther west, in the lands of ancient Mesopotamia, people had their own interpretations. In Babylonian culture, the sky was deeply tied to the gods and to fate itself. The Milky Way was sometimes seen as the tail of the great sky dragon Tiamat, or as a divine river used by the gods. The Babylonians believed that the heavens mirrored the earth below, so it felt natural to them that this bright path in the sky might reflect the rivers flowing on the land, perhaps their own great rivers, the Euphrates or the Tigris, stretching all the way into the stars. Across Africa, beliefs about the sky changed from place to place. Among the San people of the Kalahari Desert in southern Africa, the Milky Way was thought of as the spine of the night itself. Some stories said it was dust rising from the footsteps of people walking toward the next world. It was believed to show spirits where they needed to go. In Northern Europe, the Scandinavians had their own way of seeing it. The Milky Way was imagined as a road used by the gods. It may have been seen as a frozen bridge in the sky, something that connected the human world to Asgard. Norse myths are often remembered for tales of Thor and Odin, but they also describe a sky filled with meaning, where each star had a quiet influence on human destiny. Among Native American cultures, the stories were often softer and more poetic, shaped by the rhythms of nature. The Inca did not view the Milky Way as just a line of stars. They also noticed the dark patches within it. To them, these were not empty spaces. They were living shapes in the sky, animals like a llama, a fox, and a snake. These forms mattered deeply. The Inca watched how they shifted with the seasons and used them to decide when to plant, when to harvest, and when to hold ceremonies. None of these ancient peoples could have known that what they were seeing was the edge of a spiral galaxy. They could not imagine that the stars above them were only a small part of a system stretching across billions of light years. Realizing that the stars themselves were moving meant letting go of beliefs that had lasted for thousands of years. For a very long time, people believed the earth was still and unmoving, the center of everything. The sky looked like a vast dome turning around us. The sun rose and set. The stars moved in circles overhead. The moon followed its own path. To the human eye, this all felt reasonable. The ground beneath our feet seemed solid and still. Everything else appeared to move around us. It felt safe to believe that Earth, and therefore humanity, stood at the center of the universe. Many respected thinkers supported this idea. The Greek philosopher Aristotle believed the heavens were perfect and unchanging, with Earth fixed at their center. Later, the astronomer Ptolemy created a detailed model based on this belief. In his system, Earth did not move. The planets, the sun, and the stars all traveled around it in perfect circles. The model was complicated, though. To explain the strange paths of the planets, it had to include smaller circles moving on top of larger ones. Even so, it seemed to match what people saw in the sky. For more than 1,000 years, this view was taught as unquestionable truth. It shaped how people understood the universe, their place in it, and even how they thought about time. Then, In the 1500s, a quiet but unsettling idea began to grow. A Polish astronomer named Nicolaus Copernicus started to wonder if the old model truly made sense. The movements of the planets felt awkward and messy. Some even appeared to move backward. Copernicus began to suspect the problem was not the planets, but our point of view. He suggested something radical. What if the sun was at the center instead of Earth? What if Earth rotated and slowly traveled around the sun each year? Suddenly, the strange backward motion of the planets became much easier to understand. The idea was simple and elegant, but also deeply disturbing. Copernicus knew how dangerous it could be. He waited until the very end of his life to publish his work. In 1543, he likely never realized how much his idea would change the world. At first, the shift was slow, but everything changed when an Italian named Galileo Galilei entered the story. In the early 1600s, telescopes had just been invented, and Galileo was among the first to point one at the sky. What he saw was shocking. The moon had mountains and craters. It was not smooth or perfect. Dark spots moved across the surface of the Sunday, and Jupiter had moons of its own, clearly orbiting it. This was undeniable proof that not everything revolved around Earth. He also noticed that Venus, much like the moon, goes through phases. There was only one way to explain this. Venus had to be moving around the Sunday. All of these discoveries were pointing to the same truth, again and again. Earth was not at the center. The old models simply could not explain what the telescope was now revealing. When Galileo shared his findings, the reaction was harsh. The established order, along with religious authorities, saw these ideas as dangerous, but it was already too late. The telescope had shown too much. The genie was out of the bottle. As the years passed, Johannes Kepler discovered that planets do not move in perfect circles, but along stretched paths called ellipses. Later, Isaac Newton explained why they move this way, revealing the laws of gravity. The solar system began to look less like a mystery and more like a vast machine, governed by clear rules. Yet this new understanding opened the door to a far more unsettling question. If Earth was not at the center, and if the sun was just another star, then what were all those other points of light in the sky? As telescopes improved, it became clear that the night sky was filled with countless stars, invisible to the naked eye. Stars were no longer decorations on a black dome. They were suns in their own right, enormous spheres of energy, burning quietly in the deep darkness at unimaginable distances. Suddenly, the universe felt much larger. After coming to terms with the idea that Earth orbits the sun, we were forced to accept something even more humbling. The sun itself was only one star among billions. And all of those stars belonged to a greater structure, one we would later call the Milky Way Galaxy. After thousands of years of believing that everything revolved around us, we were beginning to realize that we were more like drifting dust, carried along inside something vast and deep. When telescopes revealed that the Milky Way's glow came from millions of stars, humanity faced yet another question. What shape did this enormous structure have? This was not easy to answer. Our greatest obstacle was our own position. We live inside the Milky Way, buried deep within one of its arms. It is like standing in the middle of a dense forest and trying to draw its shape from above. You can see the trunks and branches around you, but the full pattern The edges of the forest lie far beyond your view. There was another problem as well: cosmic dust. Thick clouds of gas and dust drift between the stars, blocking visible light. Even when distant regions of the galaxy shine brightly, their light never reaches Earth. The dusty lanes of the Milky Way act like heavy curtains, hiding much of the view. For many years, this slowed progress. In the late 1700s, an astronomer named William Herschel dared to try anyway. He counted stars across the sky and created a rough map. He suggested that the galaxy was shaped like a flattened disk, but because he did not account for dust, he reached the wrong conclusion. It seemed to him that the sun lay near the center, since the number of stars looked similar in every direction. In reality, it was like looking at a street lamp on a foggy night. You only see what is close. The true scene remains hidden behind the mist. Everything changed when scientists learned to look beyond visible light. Light is not limited to the colors our eyes can see. There are shorter wavelengths, like ultraviolet and X-rays, and much longer ones, like infrared and radio waves. These longer waves have a special ability. They can pass through dust. Radio waves can travel through thick clouds of gas and dust with very little interference. The key to revealing the true structure of our galaxy was hidden in these invisible signals. By the middle of the 20th century, radio astronomy was born. Instead of glass lenses, massive metal dishes began listening to the sky. One of the most important discoveries came from hydrogen, the most common element in the universe. Cold hydrogen atoms drifting between stars emit a very specific radio signal with a wavelength of 21 centimeters. The signal is incredibly faint, but sensitive radio telescopes can detect it. When astronomers began tracing this signal across the sky, they noticed something unexpected. The hydrogen gas was not scattered randomly. It followed long, curved paths circling the galaxy's center. These were the spiral arms. For the first time, it became clear that the Milky Way was not a smooth cloud of stars, but a structure with graceful arms winding outward from its heart. As technology moved forward, infrared telescopes entered the picture. These observatories were sent into space to escape the limits of Earth's atmosphere, allowing them to sense heat, the quiet warmth released by stars and clouds of gas. For the first time, we were able to look straight into the dusty heart of the galaxy, deep into its crowded core. What we found was not simple or clean. It was a dense, tangled region filled with old stars, layered and complex. Most importantly, we realized that the central group of stars was not shaped like a perfect sphere. Instead, it was stretched out, forming a long, bar-like structure. This meant that our galaxy was not just a spiral, but a barred spiral galaxy. The elegant form we had seen in many distant galaxies turned out to describe our own home as well. When radio maps and infrared maps were combined, the Milky Way appeared in a new way: a thin disk with sweeping spiral arms, a thick bulge at the center, and surrounding it all, a vast halo made of ancient stars and mysterious dark matter. We now understand this much: that pale band of light in the sky is a rotating, living system, home to billions of stars, a kind of cosmic city, and we are not at its center. We live far from downtown, out on a quiet arm, among giants. Centuries of patient observation and the effort to see what cannot be seen have finally given us our true address. we are no longer just looking upward. We know where we are looking from and where we stand within that deep darkness. With our telescopes, we can see distant galaxies in all their beauty. When we look at Andromeda, we can take in its spiral arms, its bright core, its grand structure, all at once. But we do not have that luxury with the Milky Way. A true photograph of our galaxy from the outside has never been taken and likely will not be for a very long time. Because we are not observers watching the scene, we are part of it. Those stunning images of the Milky Way you see are not photographs. They are careful reconstructions, built from data and imagination working together. It is like trying to draw the blueprint of a massive building you can never leave, based only on the view from its windows. To complete this map, astronomers rely on a tool that studies how light and radio waves move, the Doppler effect. We experience it in everyday life. When a train rushes past you, its sound becomes higher as it approaches and deeper as it moves away. The waves are compressed, then stretched. The same rule applies to light and radio waves. Light from gas clouds and stars in different parts of the galaxy shifts slightly, depending on whether they are moving toward us or away from us. By measuring these shifts in hydrogen's faint 21-centimeter signal, scientists can calculate how the gas moves and how fast the galaxy rotates. Slowly, the skeleton of the Milky Way emerges from the dark. We now know that our galaxy has 4 main spiral arms: Norma, Scutum, Centaurus, Sagittarius, Perseus. These arms stretch outward from the ends of the central bar, curving gracefully into space. But these arms are not solid structures. They are more like traffic jams in the flow of the galaxy. Stars and clouds of gas drift into them, slow down, compress, and briefly shine brighter. Then they move on. The arms are where the galaxy's youngest, hottest, and brightest stars are born. So where are we in all of this? The solar system is not near the center. We are not even sitting directly on one of the major spiral arms. Our home lies in a smaller structure known as the Orion Arm, or the Orion Spur. It is a modest bridge stretching between the massive Sagittarius and Perseus arms. We live in a relatively quiet suburb, far from the heavy traffic and chaos. This position may be more than chance. It may be part of why we are here at all. The main arms are dangerous places, filled with intense radiation, frequent supernova explosions, and violent interactions. Between them, in this calmer gap, the Orion Spur offers a kind of safe harbor. We are about 26,000 light-years from the galactic center, far enough to avoid its deadly crowding, yet close enough for the elements needed for life to exist. Grasping the size of our galaxy is almost impossible for the human mind. The Milky Way's disk spans roughly 100,000 light-years from one edge to the other. Even light moving at 300,000 kilometers per second would take 100,000 years to cross it. Our sun and the planets around it are nothing more than microscopic points within this vast, rotating disk. That hazy band you see in the night sky is simply this disk viewed from the inside. We sit close to the edge of the plate, looking inward toward its center. The sheer number of stars, combined with thick clouds of dust, comes together to create that soft, milky glow. Years of careful mapping, missions like Gaia, and incredibly precise measurements have slowly cleared this fog. We now understand that we are not floating on the surface of a calm lake. We are inside a fast-spinning, living structure, filled with stars and powered by immense energy at its core. And this structure continues to turn quietly through the dark, carrying its own unseen rhythm. The Milky Way is not still. It is a gigantic wheel in motion. Everything within it, our sun, our planets, every star we can see moves along with this rotation. The solar system travels through space at an astonishing speed of about 828,000 kilometers per hour. Yet the motion is so smooth and the scale so enormous that we feel nothing at all. The journey is long. One full orbit of the Sun around the galactic center takes about 230 million years. We call this a galactic year. The last time the Sun passed through this same region of the galaxy, dinosaurs were only beginning to dominate Earth, and the continents were arranged very differently. We are moving along the hand of a cosmic clock, turning so slowly that a human lifetime cannot sense it, yet unable to stop. In the 20th century, when astronomers studied this motion in detail, they encountered something deeply strange. According to the laws of gravity we know, objects orbiting a center should move more slowly the farther they are from it. Our own solar system shows this clearly. Mercury races around the Sun, while distant planets like Neptune move much more slowly. Gravity weakens with distance. Scientists expected the galaxy to behave the same way. Stars near the crowded center should move faster, and stars farther out should slow down. But the data said otherwise. Stars at the edges of the galaxy were not slowing down at all. Many were moving just as fast as those closer to the center. This created a crisis. A galaxy rotating this quickly should tear itself apart. Imagine a spinning carousel. If it turns too fast, everything on it is thrown outward. By all known rules, the outer stars should have been flung into space, but they were not. The visible matter, stars and clouds of gas, did not provide enough gravity to hold the galaxy together. Mathematically, it should have fallen apart, yet it remained intact. Something unseen was holding it in place. A massive presence that did not shine, did not emit light, and could not be seen by telescopes, but revealed itself through gravity alone. This invisible substance was named dark matter. It was not unique to our galaxy. Every galaxy studied showed the same effect. Dark matter does not reflect light, absorb it, or interact with it in any familiar way. Its presence is known only by how strongly it pulls on visible matter. This discovery completely changed how we understand the Milky Way. We once imagined it as a flat disk made only of stars. Now we know that this disk is embedded inside a much larger, invisible sphere, a dark matter halo stretching far beyond the galaxy's visible edge, out to nearly 300,000 light-years from the center. The bright disk of stars is like a small jewel set deep within this enormous, unseen structure. Dark matter acts as a cosmic glue. Without it, the spiral arms could not hold their shape, and our sun would not remain bound to the galaxy. Perhaps the most striking realization is how incomplete our view of the universe truly is. If you gather every star, every planet, every gas cloud, and every glowing nebula in the Milky Way, you account for only about 10 to 15% of its total mass. The remaining 85 to 90% is dark matter. We are like foam on the surface of a vast ocean. We see the shining bubbles, but not the ocean itself, the deep, dark mass beneath. Stars are not the true rulers of the galaxy. They are decorations, arranged along the skeleton of dark matter, This invisible foundation shapes not only the galaxy's structure, but also its evolution, its interactions with others, and its ultimate fate. When we look at the night sky now, we understand that the light we see is cradled by something far larger and unseen. Yet the visible disk, the thin layer where stars, gas, and life exist, is far from smooth or still. For a long time, we imagined the Milky Way as a perfectly flat plate drifting through space. Modern radio maps and space telescopes shattered that idea. Our galaxy is bent. Its edges warp upward on one side and dip downward on the other, like a vinyl record left too long in the heat. This bending is known as the warp, and it affects stars and gas in the outer regions. Surveys of hydrogen gas show that the warp is uneven and constantly changing. What causes this distortion? The Milky Way has not lived a quiet life. It is surrounded by smaller galaxies, many of which have collided with it or passed close by in the past. These encounters tug at the outer disk through gravity, like pulling on the edge of a blanket. Over time, these repeated interactions leave lasting marks on the galaxy's shape. One of the main suspects is the Large Magellanic Cloud. It is massive enough to disturb our galaxy, and even now, as it orbits nearby, its gravitational pull may be sending ripples through the disk. Another possibility lies in the dark matter halo itself. If this invisible halo is uneven or off-center, it could be pulling the disk in different directions, causing it to bend. Farther out, the disk does more than bend. It spreads. This effect, known as flaring, causes stars in the outer regions to occupy a thicker, wider space, rather than a thin plane, much like the thicker crust at the edge of a pizza. These outer regions are fragile. They are easily disturbed by passing galaxies or clumps of dark matter. Such interactions heat the stars, give them extra energy, and push them into wider, vertical motions. All of these features, warps, ripples, and flares, show that the Milky Way is not a frozen monument. It is alive, breathing, and constantly shaped by its surroundings. The Gaia satellite has captured this motion in stunning detail. Stars do not merely orbit, they also move up and down, vibrating in response to ancient collisions and gravitational shocks. Our galaxy carries the scars of billions of years of violent history and continues to evolve even now. And next, we turn our journey toward the most mysterious region of all. As we move away from the quiet outer edges of our galaxy and slowly head inward, everything begins to change. The calm disappears. We are no longer in the familiar safety of the Orion Arm. This is the Milky Way's core, crowded, restless, and intense. At first glance, we might expect the center to look like a bright, round glow. But thick dust clouds hide it. Only when we look in infrared does the truth emerge. The center is not a smooth sphere. Instead, a long bar of stars stretches across the galaxy, like a backbone running through its heart. This bar is not rare. Many spiral galaxies have one. It forms slowly, shaped by gravity and motion over billions of years. Stars and gas are pulled into looping paths. The original round shape stretches and thins. From certain angles, the structure even resembles a giant X, a quiet reminder that the galaxy grew through movement, not calm stillness. This bar is more than a shape. It plays an active role. As it turns, it guides gas inward, feeding new stars and sending material toward the very center. The closer we get, the more crowded space becomes. Near our Sun, the nearest star is over 4 light-years away. That distance feels empty and peaceful. But near the center, stars sit far closer together, packed tightly into a small region. Millions of them circle the same point at incredible speed. If Earth were here, night would never truly arrive. The sky would glow endlessly, lit by countless suns, like an eternal dawn. Hidden within this crowded region are some of the galaxy's strangest star clusters. One of them is the Arches cluster. It lies only a few dozen light-years from the center and contains enormous young stars, many more than 100 times the mass of our Sunday. These stars live fast. They release powerful winds and flood their surroundings with harsh radiation. They burn through their fuel quickly. In just a few million years, many will explode, scattering heavy elements into space. Nearby is another massive group, the Quintuplet cluster. Its stars are older. Some have already swollen into red giants, shedding layers of dust. Others may have already died, leaving behind neutron stars or black holes. Together, these clusters reveal the nature of the galactic center. It creates stars with ease, yet destroys them just as readily. This place feels nothing like empty space. Gas is twisted by magnetic fields. Radiation breaks molecules apart. Stars constantly tug at one another through gravity. How stars form here at all remains uncertain. Some scientists believe these clusters were born elsewhere and drifted inward. Others think gravity still finds a way, even in chaos. This region is where the galaxy's past meets its future. Old red stars carry ancient stories. Young blue stars hint at what is still to come. And beneath all of it, there is something else, something unseen, a single point that everything moves around. That destination lies at the center of it all, Sagittarius A*. For years, astronomers saw nothing there. No bright object, no massive star, only a small, intense radio source hidden behind dust. They named it Sagittarius A*. To understand it, they watched the stars nearby. Those stars move differently. They do not drift calmly. They race around an invisible center at extreme speeds. One star, called S2, became especially important. S2 completes an orbit in just 16 years. Our Sun takes 230 million years to do the same. At its closest point, S2 comes within a few billion kilometers of the center and reaches speeds over 4,000 kilometers per second. Nothing ordinary could cause this. Only a massive object packed into a tiny space could hold a star like that. The numbers were shocking. 4 million times the mass of the Sun, squeezed into a region smaller than Mercury's orbit. That could only mean one thing: a supermassive black hole. Yet Sagittarius A times is surprisingly quiet. It is not constantly feeding. On human timescales, it barely stirs. Scientists often call it a sleeping giant. Most of the time, there is nothing for it to consume. It waits, still, patient. Sometimes, something drifts too close. A gas cloud, a fragment of a dead star. As the material falls inward, it heats up, glowing briefly before vanishing. For a moment, the black hole awakens. A flash of energy appears, Then silence returns. At the center of our galaxy, the darkness remains, quiet, invisible, and always there. These flares are brief, sometimes just a few hours, but what they remind us is important. The giant at the center may be sleeping, yet it is still there, still incredibly powerful. As technology advanced, we got closer to seeing it. The Event Horizon Telescope achieved the impossible with a network spanning the globe. In 2022, it revealed the shadow of Sagittarius A*. It wasn't a traditional photograph. Data from radio waves created an image, a dark center surrounded by a glowing orange ring. The center is a place where even light cannot escape. Einstein's theories were proven right once again. Now, we don't just infer the presence of the black hole from star movements. We can witness it directly. At the heart of our galaxy sits a silent observer, 4 million times the mass of our Sun, bending space and time itself. Sagittarius A times may be dormant today, but this doesn't mean it's always silent. The ghosts of past violent outbursts still linger here. In 2010, the Fermi Gamma Ray Space Telescope turned to the galactic center and discovered something unexpected. The sky isn't only filled with stars. Enormous structures of energy exist that are invisible to our eyes. The Fermi bubbles. Each bubble stretches nearly half the size of our galaxy. They rise 25,000 light-years above and below the galactic plane. It's as if someone inflated 2 giant balloons from the center of the galaxy, filled not with air, but with gamma rays and near light-speed particles. The human eye cannot see them. For millions of years, they've hovered silently above us, only now coming into view. These bubbles show us that the Milky Way is not still. It breathes. It pulses. It expels energy into space. What keeps it all together? An invisible skeleton, gravity, and magnetic fields. Just like Earth has a magnetic field, we cannot see it, but it shapes gas clouds, guides cosmic rays, and even controls where stars are born. The sharp edges of the Fermi bubbles are likely held by this invisible magnetic web. The Milky Way is not just a spinning disk of matter. It is a storm of mass, electricity, and magnetism. Sagittarius A times sits at its eye. Sometimes it waits silently. Sometimes it spews giant energy bubbles that ripple across the galaxy. Now we move away from the center toward colder, quieter, and just as mysterious outer layers, the stellar halo. Beyond the bright arms and the crowded heart of the Milky Way, we find vast emptiness. A mostly dark, almost ghostly sphere surrounding the galaxy, the halo. Here, there are no young, bright stars, no dense gas clouds, only scattered, lonely stars drifting far apart. This is the galaxy's cosmic graveyard. Most of these stars are ancient. Some are billions of years older than the Sunday. Some were born here, but many are foreigners. Long ago, smaller galaxies were destroyed and absorbed by the Milky Way. The halo quietly preserves their story. Stars in the disk move in order, all together. Stars in the halo move randomly. Some orbit backward. Some take billions of years to complete a single revolution. These stars tell the tale of the past. When smaller galaxies fall into larger ones, stars stretch into long streams. This process is called galactic cannibalism. One of the most famous examples is the Sagittarius stream. It comes from the Sagittarius dwarf elliptical galaxy. Long ago, it passed close to the Milky Way and began to break apart. Its stars wrapped around our galaxy like ivy, traces we can still see today. We can even tell where a halo star came from by its chemical composition. Most are metal-poor hydrogen and helium dominate. They are relics from the early universe, fossils of a time before heavier elements existed. At first glance, the halo may seem empty, but it holds billions of years of collisions, swallowed worlds, and the toll the Milky Way paid to reach its present form. The Milky Way may appear like a calm river, but it is a growing, feeding giant, still in motion. Even now, other galaxies orbit around it, waiting to be absorbed. Beyond the familiar spiral arms, in the southern skies, two bright spots catch our eye: the large and small Magellanic Clouds. They appear like clouds torn from the sky, but they are galaxies in their own right. The Large Magellanic Cloud lies 160,000 light-years away. It hosts bright young stars and dense gas clouds shaped like a distorted spiral. Its smaller companion, the Small Magellanic Cloud, is farther, 200,000 light-years, and even more chaotic. These two galaxies do not just orbit the Milky Way. They are also bound to each other, moving together in a gravitational dance across space. This gas stream tells a story of loss. As the Magellanic Clouds move through the Milky Way's halo, they slowly shed their gas. But for our galaxy, this loss is a gain. When the gas finally slows and falls onto the outer disk, it becomes fresh fuel. It can awaken the sleeping regions of the Milky Way, sparking unexpected new star formation. Even as our neighbors slowly erode, they continue to nourish the galaxy. The interaction is not one-sided. For a long time, we thought the Large Magellanic Cloud was a passive satellite. New data shows it is far more massive than expected, perhaps 10% the mass of the Milky Way. It is not just an observer, but a powerful player. As it orbits, the Large Magellanic Cloud tugs, bends, and reshapes the Milky Way's disk. Even the invisible dark matter halo bears its mark. Like the wake of a boat on water, it creates ripples in the dark matter, causing the center of our galaxy to shift or tremble slightly. This is proof of how dynamic the universe is. Nothing, even the largest galaxies, exists in isolation. Gravity binds everything together with invisible threads. Life inside the Magellanic Clouds feels this pull too. Galactic interactions compress gas, accelerating star formation to incredible rates. The Tarantula Nebula inside the Large Magellanic Cloud is the most active and massive star nursery in the local universe. If it were as close to us as the Orion Nebula, about 1,300 light-years away, it would appear as large as a full moon and shine so brightly it would cast shadows at night. This violent cycle of creation and destruction is part of a process with a destined end. Models predict the Magellanic Clouds will not orbit the Milky Way forever. They are losing energy, slowing down, shrinking. Billions of years from now, they will be completely torn apart and merged into the Milky Way. The bright spots we see today will dissolve into the galaxy's massive disk and halo, their stars blending with ours. But until then, the cosmic dance continues. Gas streams flow, new stars ignite, and the Milky Way continues to be sculpted by these persistent neighbors. Looking around the Milky Way, we see several dozen satellite galaxies like the Magellanic Clouds, or the Sagittarius dwarf galaxy. At first glance, it seems like a crowded little family. But when astronomers run computer simulations of the Milky Way's formation, a very different picture emerges. Models suggest a galaxy as massive as ours should be surrounded by hundreds, even thousands of small satellites. The enormous gap between theory and what we observe is one of modern astrophysics' greatest mysteries, the missing satellites problem. Where are these galaxies? Are our models wrong, or are they there but invisible to us? The answer likely lies in one of the universe's darkest secrets: dark matter subhalos. The Milky Way's halo is not a smooth sphere. Like lumps in dough, there should be smaller concentrations of dark matter subhalos within it. In the early universe, some of these may have captured gas and tried to form stars, but some were too small, or early radiation heated and expelled the gas. Star formation never began or stopped prematurely. If this scenario is correct, the Milky Way could be surrounded by hundreds of invisible ghost galaxies, made entirely of dark matter. They emit no light and cannot be seen with telescopes. We can only detect them through their gravitational effects. These invisible masses drift through space, sometimes crossing star streams like a rock thrown into a calm river, creating gaps, twists, and dispersions in the streams. Astronomers today study stellar streams in the Milky Way's halo to track these unseen disruptors. Not all missing satellites are completely dark. Some may be ultra-faint dwarf galaxies, in a gray zone between existence and absence. They are so dim that they may contain only a few hundred or thousand stars. At first glance, they look more like scattered star clusters than galaxies, but their motions reveal they are held together by massive unseen gravity. They are tiny, barely glowing islands embedded in dark matter. Detecting these faint ghosts is extremely difficult. They are often lost among background stars or cosmic noise. Even the Milky Way's own disk blocks our view. The zone of avoidance, where the dense star and dust band of the galaxy lies, hides what is behind it. Perhaps some of the missing galaxies are right in front of us, concealed by the galactic disk. As technology advances, this dark curtain is slowly lifting. Next-generation telescopes, like the Vera Rubin Observatory, aim to repeatedly scan the sky, capturing the faintest and fastest moving objects. Each new discovery reminds us the halo is not empty. It is crowded with dark masses. And perhaps the most striking thought is this: the stars we see at night are only the luminous surface of our galaxy. In reality, we are surrounded by starless galaxies, faded remnants, and lumps of dark matter. The Milky Way lives in a far more complex and crowded neighborhood than it appears. Most of our neighbors are quiet ghosts, reluctant to show themselves. Now, we turn from these ghosts to focus on the galaxy's oldest residents, the ancient stars that have witnessed the beginning of time. At the edge of the galaxy, where the familiar spiral arms end and deep space begins, a lone star drifts silently. At first glance, it looks like any of the billions of points in the sky. It is not the brightest, the largest, or even one of our closest neighbors. In catalogs, it is known by a technical code name, HD 140283. Yet astronomers have given it a far more meaningful name, Methuselah, named after the longest-lived figure in sacred texts, said to live nearly 1,000 years. It truly lives up to its name. because it is older than almost everything we know in the universe. Methuselah lies about 190 light-years from us, cosmically speaking, practically in our backyard. Yet its story stretches far beyond this proximity. When scientists analyzed its light and chemical composition, they discovered something astonishing. Stars are cosmic factories, forging elements throughout their lifetimes. They convert hydrogen into helium, helium into carbon, oxygen, and iron. When a star dies, it spreads these heavy elements into space, enriching the gas from which new stars are born. That is why relatively young stars, like our Sun, are rich in metals. Methuselah is different. It contains almost no iron or carbon, nearly pure hydrogen and helium. This chemical purity is conclusive evidence of its birth in the universe's earliest era, when heavy elements had not yet polluted the cosmos, and even galaxies were just beginning to take shape. It is a cosmic fossil, but this fossil sparked a crisis in the scientific world. Early precise measurements suggested Methuselah was roughly 14.5 billion years old. The problem? Modern cosmology estimates the universe itself to be only 13.8 billion years old. An impossible paradox stared us in the face. How could a star be older than the universe it inhabits? Could a child be born before its mother? This age crisis forced astronomers to rethink everything. Either our knowledge of the universe's age was wrong, or our models of stellar evolution contained a fundamental flaw. Methuselah alone threatened to shake the foundations of modern astrophysics. To solve the mystery, scientists turned to the Hubble Space Telescope. They measured the star's distance, luminosity, and surface temperature with unprecedented precision. Determining a star's age depends on knowing its distance accurately. Misjudge the distance, and you misjudge its true brightness, and thus its lifetime. With Hubble's sharp new data, calculations were updated, along with models of nuclear reactions and elemental distribution in the star's core. The results finally resolved the paradox, yet Methuselah's grandeur remained. The new estimate placed its age at 2 billion years, comfortably within the universe's limits, but still ancient. Methuselah began shining shortly after the first generations of stars, mere hundreds of millions of years after the Big Bang. Its orbit is as fascinating as its age. Unlike our Sun and other disk stars, it does not follow a calm, circular path. It moves along a vast, elliptical orbit that slices vertically through the galactic disk at dizzying speeds of 1.3 million kilometers per hour. This unusual orbit reveals its origin. Methuselah is not native to the Milky Way. It likely formed in a small dwarf galaxy that was swallowed and torn apart by the Milky Way billions of years ago. When its home galaxy was destroyed, Methuselah survived and was flung into our halo. Now, like a refugee wandering among the ruins of its birthplace, it drifts silently through the galaxy. It is not just a glowing ball of gas. Methuselah is a living record of the dawn of the universe, a witness to galactic collisions and the construction of the Milky Way itself. It whispers a profound truth. Stars have a history, and every point of light in the sky carries a tale billions of years in the making. History is often about kings, wars, and empires, but the sky has its own history. It is not written in dusty books, but in the light and motion of stars. For centuries, astronomers had to rely on snapshots of the galaxy to understand its past. We knew where stars were, but not where they came from or where they were going. It was like trying to understand the life stories of people by looking at a single photo of a busy city square. Who was local? Who was a visitor? Who was just passing through? There was no way to tell. But in 2013, a spacecraft shattered that silence. The European Space Agency's Gaia telescope was launched to undertake humanity's most ambitious stellar mapping project. Its mission: measure not just the positions, but also the motions, brightness, and distances of over 1 billion stars in the Milky Way. Gaia turned a static image of our galaxy into a dynamic, unfolding movie. We could now rewind time and see where stars were billions of years ago. By 2018, analysis of Gaia's data revealed a shocking pattern. Most stars in the Milky Way's disk rotate in orderly paths around the center, like water droplets flowing in a river. But among them, a rebellious group defied the current. Thousands of stars moved opposite to the galaxy's rotation, along elongated, plunging orbits. Chemical analysis confirmed the truth. These stars were different. They carried a foreign DNA. They were outsiders. When combined, the data revealed one of the Milky Way's most dramatic events. About 10 billion years ago, when the universe was still young, the Milky Way experienced a catastrophic collision. A dwarf galaxy, roughly the size of the small Magellanic Cloud, struck the young Milky Way head-on. Astronomers named this lost galaxy Gaia Enceladus. Its remnants stretch across the data in long, sausage-shaped patterns, sometimes called the Gaia sausage. The collision was violent. The incoming galaxy was destroyed, scattering its stars into our galaxy, creating the counter-rotating population we observe today. But it did more than destroy a galaxy. It reshaped the Milky Way itself. The energy of the collision heated and thickened the previously thin, smooth disk. The older stellar population now, found above and below the thick disk, is likely a direct result of this ancient crash. Thanks to Gaia, we now view the Milky Way as an archaeologist views ancient ruins. This field galactic archaeology reveals past galaxies the Milky Way has devoured by studying stellar motions and chemistry. Gaia Enceladus was not alone. Evidence of other collisions, like Sequoia and the Helmy Stream, is also present. These discoveries prove the Milky Way did not form peacefully. It is the sum of billions of years of violent mergers, shattered neighbors, and stolen stars. Every star in the sky carries its story. Some were born here. Others are refugees from long-vanished worlds. Gaia taught us that stars are not just points of light. They are pieces of a cosmic puzzle, and by assembling them, we begin to write the true history of our galaxy. Understanding the history of stars and the Milky Way's turbulent past is mesmerizing. Yet when we look at the night sky, the deepest question is not about history. It is about life. Are we alone? In this search, our eyes turn not to bright sun-like stars, but to the galaxy's most numerous inhabitants, tiny, faint, cool red dwarfs. If life is common, it is likely hidden around these dim suns. One system in the constellation Aquarius, about 40 light-years away, has fueled our hopes. TRAPPIST-1. This star is so small that its mass is barely 10% of the Sun's, and its size is comparable to Jupiter. It is invisible to the naked eye. Yet in 2017, astronomers discovered 7 rocky planets orbiting this dim star, a record for the most Earth-sized worlds found around a single star. The system is incredibly compact compared to our own solar system. If TRAPPIST-1 were placed in the Sun's position, all 7 planets would fit well inside Mercury's orbit, or even closer. Despite their proximity to the star, these planets do not scorch away. TRAPPIST-1 is extremely cool, and its low heat allows for temperate conditions on these close-orbiting worlds, where liquid water could exist. At least 3 of the 7 planets lie within the star's habitable zone. From their surfaces, their sun would appear as a gigantic salmon-colored sphere, while neighboring planets would drift across the sky like moons, detailed and bright. Yet the story has a dark side. Red dwarfs live long, but in their youth, they are extremely violent, frequently producing massive flares. These intense bursts of radiation can strip nearby planets of their atmospheres and sterilize their surfaces. Additionally, these planets are likely tidally locked, meaning one side always faces the star while the other remains in perpetual darkness. Life, if it exists, would have to cling to a narrow twilight zone, a thin boundary between extremes, where stormy winds rage across the surface. Proxima b, orbiting our nearest star, Proxima Centauri, shares a similar fate. It is close, rocky, but constantly bombarded by stellar radiation. In the search for life, distance from a star is not the only factor. A star's position within the galaxy also matters. Just as cities have neighborhoods suitable for life and those that are not, galaxies have their habitable zones. Astronomers believe being too close to the galactic center is disastrous. Dense stellar traffic, frequent supernovae, and enormous radiation waves would prevent complex life from ever taking hold. It is like living in a city center where fires constantly rage. Yet moving to the outermost suburbs is not a solution either. Stars are sparse. The environment is calm, but outer regions are extremely metal poor. Elements like carbon, oxygen, iron, and silicon, essential for rocky planets and life, are scarce. Without these building blocks, only gas giants can form. Earth-like, solid worlds would be impossible. Our solar system lies in the Goldilocks zone of the galaxy, about 26,000 light-years from the center. It is neither too chaotic to destroy life, nor too barren to build planets. Perhaps the uninterrupted development of life and the rise of an intelligent civilization on Earth depended entirely on this cosmic real estate. We may live in the galaxy's safest, calmest, and most fertile oasis. Yet this oasis may also condemn us to profound silence and isolation. The Milky Way's immensity is dizzying. It hosts hundreds of billions of stars, and recent discoveries suggest most of them have planets. Many of these planets lie in temperate zones where liquid water could exist. Even in our galaxy alone, there may be billions of worlds suitable for life. Statistically, life should be abundant in the universe. Logic tells us that civilizations as advanced or far more advanced than ours should exist somewhere out there. Yet when we turn our telescopes skyward, we encounter only deep, cold, unbroken silence. No signals, no messages, no traces of cosmic engineering. The sky is quiet. The stars are silent. This unsettling discrepancy is known as the Fermi paradox, named after physicist Enrico Fermi. In the 1950 seconds, during a casual lunch, Fermi asked a simple yet devastating question. Where is everybody? The galaxy is 13 billion years old. Our Sun and Earth formed just 4.5 billion years ago. Countless stars and planets existed long before us. If intelligent life arose elsewhere, it could be millions of years ahead technologically. Even at sublight speed travel, it could have colonized the entire galaxy. We should see evidence, massive structures, communication networks, traces of engineering. But we see nothing. This silence inspires chilling possibilities. Perhaps the answer lies in time. The galaxy may be old, but the conditions for intelligent life might be recent. Heavy elements, planet formation, and the complex steps of biological evolution may have taken billions of years. We may be the first civilization to awaken in this vast stage. If so, searching for others is futile. There is no one to speak to. The silence is the sound of our solitude. Another possibility is the zoo hypothesis. Advanced civilizations may exist, know about us, but deliberately avoid contact. Like humans observing a remote wildlife reserve, they may watch without interference, ensuring our development remains unaltered. A darker explanation concerns the nature of life itself. Life may frequently arise, but intelligence and technology rarely emerge. Or worse, civilizations may self-destruct once they develop star-faring technology. Nuclear wars, artificial intelligence, disasters, environmental collapse. Perhaps every advanced civilization encounters a great filter before reaching the stars. The silence of the sky could be the calm of countless failed civilizations' graves. Finally, it may be our methods that are flawed. We've listened to the sky for just half a century, primarily through radio waves. Perhaps other civilizations abandoned radio long ago. They may communicate via lasers, neutrinos, or technologies we can barely imagine. Like an ant trying to detect Wi-Fi signals, we could be in the midst of a cosmic communication network, yet hear nothing. Whatever the reason, the only reality we have for now is this profound silence. It terrifies us and drives us forward, because if we are alone, it means we are the sole guardians of life in this universe. If we are not, then somewhere in the darkness awaits a fate we have yet to meet. Every time we look up at the sky, we hear the echo of this question. Is there anyone else? Or are we listening only to the echo of our own voice in this immense cosmos? No matter how deep the silence, human curiosity does not give up easily. If the answer does not come to us, we go and seek it. For decades, under the SETI project, we have trained gigantic dish antennas on the sky, listening for unnatural, artificial, and orderly signals amid the natural static of space, the cries of dying stars, and the hum of gas clouds. Any whisper carrying a mathematical pattern, a rhythm, a sign of intelligence. So far, all we have heard is cosmic noise. Perhaps the problem is what we are looking for. We assume other civilizations communicate like we do through radio waves. But radio technology itself is barely a century old in our history. For an advanced civilization, radio waves may be as primitive as smoke signals. They may now communicate via lasers, neutrinos, or methods like quantum entanglement technologies we cannot yet even imagine. If that is the case, the galaxy could be brimming with messages, yet we remain deaf because we are not tuned to the right frequency. For this reason, modern astronomy has shifted strategy from listening to looking. We no longer only search for signals, we search for the physical traces of life biosignatures. A planet's atmosphere is the most honest indicator of life. By analyzing light filtered through a planet's atmosphere as it transits its star, we can detect its chemical composition: oxygen, methane, water vapor, strong indicators of biological activity. We go even further and search for technosignatures, evidence of industry, artificial chemicals, CFCs, or traces of nuclear waste in a planet's atmosphere would provide definitive proof of an industrial civilization. The search is not limited to Earth-like planets. Even within our solar system, the most promising places for life are not hot, sunlit worlds. They are icy moons. Jupiter's Europa or Saturn's Enceladus hide vast liquid oceans beneath thick ice shells. If most galactic life evolved in such dark oceans beneath ice and rock, these civilizations may have never seen the stars, other planets, or the vastness of the cosmos. They cannot hear us, and we cannot see them. On a larger scale, we look for megastructures in space. When a civilization becomes advanced enough, a planet's energy is insufficient. Its hunger for power may drive it to harvest its star's energy directly. Theoretical structures like Dyson spheres, vast solar panel farms surrounding a star, would block its light and emit infrared radiation in ways the star would not naturally produce. Astronomers closely monitor stars whose light behaves unusually or emits unexpected heat signatures. Perhaps somewhere, engineers are using their stars as giant batteries. Yet our greatest obstacle is time. Humanity has existed for only a blink in the age of the universe. The galaxy may have hosted countless civilizations, but never all at once. One rose, lived thousands of years, and vanished. Millions of years later, another arose in a distant corner of the galaxy. We are like ships that miss each other across the centuries. When we look through telescopes, we are looking back in time. Perhaps the signals we seek have already passed us, or have not yet begun their journey. Perhaps around the silent stars we see today, great empires once flourished, and now only ruins drift through the void. We are the archaeologists of the galaxy. As we search for the living voice of life, we may be witnessing only its ancient remnants. Yet even finding these remnants would prove we are not alone, that the universe once sang other songs. If we cannot hear or see them, perhaps instead of waiting, we must go and find the answer ourselves. Traveling to the stars has always been humanity's oldest and greatest dream. Yet the universe places the most rigid and difficult obstacle in front of this dream: distance. Space is literally emptiness, and that emptiness is vast enough to strain the limits of our imagination. Crossing the Milky Way from one end to the other, even at the speed of light, takes 100,000 years. We are far slower than light. Even the fastest human-made probe, the Parker Solar Probe, reaching hundreds of thousands of kilometers per hour, cannot approach even 1,000th of light speed. At that speed, reaching the nearest star, Alpha Centauri, would take thousands of years. A human lifetime is just a single breath compared to interstellar travel. If we hope to explore or colonize the galaxy, the key may not be speed, but time itself. Here, the concept of generation ships emerges. These are not mere spacecraft, they are floating cities in space, self-contained worlds carrying ecosystems, farms, water cycles, and atmospheres. The first crew to board such a ship will never see its destination. They will start the journey, their children will continue it, and perhaps their descendants' will finally set foot on a new planet. For these travelers, Earth will be nothing more than a distant blue legend from history books. Their entire universe will be the artificial world enclosed within the ship's metal walls. Constructing such a vessel is not only an engineering challenge, it is also a biological and psychological one. Protecting against radiation, surviving for centuries with limited resources, and maintaining the mental health of a closed society is far harder than keeping the engines running. Perhaps sending humans is, at least at first, the wrong approach. Flesh and bone are fragile, while metal and silicon are resilient. This is why scientists have considered von Neumann probes self-replicating machines. One probe is sent to a star. Once it arrives, it uses local asteroids and resources to create copies of itself. These new probes then journey to other stars and repeat the process. Like a virus, the population grows geometrically. 1 becomes 2, 2 becomes 4, 4 becomes 8. Even traveling far below the speed of light, this method could fill the entire galaxy with probes in just a few million years, a short span on a cosmic scale. In fact, this idea deepens the Fermi paradox. If such technology is possible, and older civilizations exist, their probes should already have reached our solar system. Perhaps somewhere, silently waiting on an asteroid or in a dark lunar crater, an unnoticed observer is already watching. Yet instead of waiting, we may choose to accelerate our own efforts. Physics forbids exceeding the speed of light, but it does not prevent approaching it. Nuclear propulsion, using controlled atomic detonations, could push spacecraft to 10% of light speed, compressing millennia-long journeys into human lifetimes. The most elegant and promising concept, however, is the light sail. Projects like Breakthrough Starshot aim to launch gram-scale probes using enormous lasers. These tiny craft could reach 20% of light speed, allowing them to reach Alpha Centauri in just 20 years. Within a single generation, we could capture close-up images of another star system. No matter how long the journey to the stars, it is not impossible. What is required is patience, courage, and imagination. The galaxy is vast, and we are small. Yet our ancestors crossed oceans in tiny wooden ships. Now, we face a dark, silent ocean, building our rafts while gazing at distant lights across the void. Yet the greatest event awaiting us is not our journey, it is a massive collision coming toward us. The future of our galaxy will inevitably be rewritten through a cosmic merger. The Milky Way is not an isolated raft drifting alone in darkness. It is part of a bustling family, the local group, composed of over 80 galaxies bound together by invisible gravitational threads. Most of these are faint dwarf galaxies, but at the center are two giants, our Milky Way and our neighbor Andromeda. These two contain nearly all the mass and light of the group, with dozens of satellite galaxies orbiting them like moons. But this family portrait is not static. While the universe expands, most galaxies drift apart. Within the local group, gravity dominates. We are not dispersing, we are falling toward each other. When we look at the night sky, Andromeda appears as a faint blur, but it is a massive spiral galaxy, far larger and richer in stars than the Milky Way, steadily approaching us at roughly 110 kilometers per second. In galactic terms, this is a slow drift, but eventually it will lead to a grand merger. In about 4 billion years, the two giants will collide. Even now, their dark matter halos are brushing against each other, stirring the outer stars and gas clouds. This will not be a metallic crash like two cars colliding. Stars are so far apart that direct collisions are nearly impossible. The encounter will be a majestic, gravitational dance. As the galaxies intertwine, their spiral arms will twist and bend, and millions of stars will be flung into long arcs known as tidal tails. Gas clouds will collide violently, triggering intense star formation starburst events that will illuminate the merging galaxies with brilliant blue light. Creation and destruction will occur simultaneously. Over billions of years, the galaxies will drift apart and fall back together repeatedly until they finally merge into a single, massive, elliptical galaxy. The Milky Way and Andromeda, as we know them, will no longer exist. Supermassive black holes at their centers will merge, forming one of the largest black holes in the universe. The new galaxy, Milkomeda, will be older, calmer, and dominated by red stars, the remnants of stars that once burned brightly. The fate of our solar system in this cosmic dance is uncertain. Simulations suggest we may be flung into a distant orbit, surviving physically but losing the familiar view of the sky. Even as Milkomeda stabilizes, the Sun itself will reach the end of its life. It will expand into a red giant, engulfing Mercury and Venus, and possibly Earth. Eventually, it will shed its outer layers, leaving a white dwarf, a slowly cooling ember. Our solar system will drift through Milkomeda, a cold, dark graveyard. Yet this is not the end. The gas expelled from the Sun will seed future stars, potentially giving rise to new worlds long after we are gone. Our story ends, but the cycle of the cosmos continues. As trillions of years pass, even the longest-lived stars will fade. White dwarfs, neutron stars, and black holes will populate an increasingly dark universe. Eventually, black holes will evaporate through Hawking radiation, leaving only emptiness. Finally, the universe will reach heat death, maximum entropy, absolute stillness. Time will lose meaning. Past, present, and future will merge into silent, infinite equilibrium. The universe, once tumultuous and brilliant, will rest in eternal calm. And now, in this ultimate silence, you too can rest. Release your thoughts, worries, and burdens into the vast cosmic stillness. Feel your body supported, held safely as gravity holds galaxies together. Breathe slowly and deeply as the stars fade. There is nothing to see, nothing to solve, nowhere to go. Only a deep, peaceful void surrounds you. Let yourself dissolve into it, like particles in a universe at rest. All struggles, collisions, flames, and explosions have ended. Everything is at peace. It is time to rest.